Hey everyone, welcome to our last lesson of this unit. So this is lesson 3.5. We aren't going to do everything. We're going to skip this idea of a directed line segment. You're going to notice a lot of stuff today is review from Algebra 1. So I sort of get excited because I love the algebra part of our geometry. So the first two theorems here are just review from Algebra 1. The idea here is that parallel lines have the same slope. Perpendicular lines, their slopes are negative reciprocals of each other. Okay, so that's just from Algebra 1. A little review on negative reciprocals. So, for example, if one line, let's say I have line A, has a, so we have line A. Helps if I can actually like write an A. Line A has a slope of 2/3. If B is perpendicular to A, then line B's slope is going to be -3/2. So one has to be positive, one has to be negative, and reciprocal basically means you're taking that fraction, flipping it upside down on its head. All right. Another example is what if one slope was 4, the negative reciprocal would be -1/4. That's because 4 can be written as 4/1. So just a little reminder of just because you don't see a fraction doesn't mean you can't flip it upside down to make a reciprocal. All right, we still can. All right, let's move on. So we're going to skip right now. We're going to skip 1 and 2. We're going to skip this directed line segment stuff. And let's just look at number 3 here. Number 3 says determine which of the lines are parallel, which are perpendicular. Now there's a lot of lines here. There are 5 lines. So I'm going to go old school and just count my slopes. But first, I'm going to write down what my lines are. Line We have A? No, sorry, I'm just starting to write random letters here. We have lines S and R, so I'm going to write their slopes. We have lines T, P, and Q. T, P, and Q. All right, I'm going to count my rise over run. So if I look at, no, I'll do each of these as a different color. Let's do S. S, I go down, if I start here, go down 1, 2, 3, and over 1, 2, 3. So down 3 and over 3 is a slope of -1. If I look at line R, here's a point, and here's another point. So go down 1, 2, 3, and then over 1, 2, 3, 4. So that's -3/4. And let's look at line T. So I have at the point -4, -1. I can go down 1, 2, 3, and over 1, 2, 3, 4. So -3/4. So I already know right now that R is parallel to T because they have the same slope. Now let's look at P, line P. Here's a point. I'm going to go, and here's a point. So I go up 2 and over 2, which is a slope of 1. And then line Q is, here's a point, and here's a point. So go up 1, 2, 3, and over 1, 2, 3, up 3 and over 3, which is 1. So I can see that P is parallel to Q. And then in terms of perpendicular, it just so happens negative reciprocals. I have that S is perpendicular to P and S is perpendicular to Q because they're negative reciprocals of each other. Now, if we wanted to get to number 4 and talk about are they parallel, perpendicular, neither, we have to do a slope formula back from Algebra 1. So that formula says y2 minus y1 over x2 minus x1. That's our slope. So change in y over change in x. So if I look at line one, I'm going to have my fraction bar, my two subtraction signs. I'm going to say 2 minus 0. That's the y's. And then for my x's, I'm going to say -2 minus 2. That's going to give me 2 over -4, which is -1/2. All right, let's go ahead and look at line 2 now. So here's line 2. All right, y2 minus y1. y2 is 4, y1 is -2. And then x2 is 4, x1 is 1. And this is going to give me 6 over 3, which is +2. Now, it just so happens these two are negative reciprocals of each other. That means line 1 is perpendicular to line 2. So they're perpendicular. All right, let's go to the next page. Write an equation of a line passing through the point that is parallel. So I'm not going to graph, I'm just going to write it. So this is really quick. This is our point slope form. So y minus y1 equals your slope times x minus x1. Review from algebra 1. And parallel, the idea here is parallel means we want the same slope. So if I'm using 2 over 3 as my slope, I want to use a slope of 2/3 with that point. So I'm going to say y minus my y value, which is -2, equals my slope, which is 2/3, times x minus my x value, which is 3. And let's do some algebra. So this is going to be y plus 2 equals 2/3 x. I'm going to multiply not only by the x, but I multiply by the -3. I'm going to get -2. And then I can subtract 2 from both sides, and my equation is going to be y equals 2/3 x minus 4. Now, if I did perpendicular, I would do the same thing, but I'd want to use a negative reciprocal slope. So on number 6, which I'm not going to do, I see my original slope was 2, so I'm going to use a slope of -1/2, which is the negative reciprocal. All right, the biggest part of the notes today is this crazy awesome algebra question of finding the distance from a point to a line. In the last lesson, we did briefly talk about to find the distance from a point to a line, the shortest distance is from the point to the line on the perpendicular of it. So step number 1 is I want you to find the perpendicular slope. Now, I'm just abbreviating here. So if my original question here says the slope is -3, I want to use a slope of 1/3. All right. Second thing is now I want to find the perpendicular equation using our point slope form. So I have a point and I have a slope. So we're going to use our point slope form. I'm going to set this up with a little template. Y minus my y value equals my slope times x minus my x value. Let's plug in our values. The y would be 5, the slope is 1/3, and the x is 0. So we're going to play some cleanup here. We get y minus 5 equals 1/3 x. 1/3 times 0 is 0. I can add 5 to both sides. So I get y equals 1/3 x plus 5. Now, what's happening here is I have an equation. I'm going to zoom out just a little bit. My original equation was something at a negative slope like this. This is my original one. My perpendicular one is going to have a positive slope that looks like this. So this is my perpendicular one. So now they're perpendicular. And I have a point here that I want to find the distance for. So now we figured out that equation. I know the point. But what I want to know is I want to know where does this new line cross my original one so then I can find this distance right here using my distance formula. So to find when two lines intersect, we can do a system of equations, and more specifically, we can just set them equal to each other. So the third step is going to be we're going to set them equal to each other. So set both equations equal to each other. And you're going to find X and Y. So I'm going to do that. I'm going to take my, sorry, this is really big here. So I'm going to try to write a little smaller now. I'm going to take my 1/3 X plus 5 and set that equal to -3x minus 5. I'm going to add 3 to both sides. So that's going to be 10 thirds x. And if I subtract 5 from both sides, that's going to give me a -10. Now, if I solve for x, I'm going to have to multiply both sides by 3/10, which is the reciprocal. So I'm going to say times 3/10, just to show you what I have, times 3/10. I get x equals -3. So there's my x value. Now, to find y, I need to plug that x back into one of my equations and then solve. So I'm going to take my original one and say, what's -3 times -3 minus 5? So I'm plugging my x value back into this equation up here that my red arrow is pointing to. And then I'm going to simplify. So I'm going to get 9 minus 5, which is 4. So that's my y value. That means I have the point -3, 4. If I go back to the picture I drew earlier, that means this is the point -3, 4. This other point was my original one, which is 0, 5. And if I want to find the distance between 2 points, I have to use my distance formula. So the last step, if I can squeeze this in here, is distance formula. So I'm going to squeeze this here at the bottom. Square root symbol. I'm going to use my parentheses squared. And I'm going to subtract my x values, and then I'm just going to let the calculator do all the heavy lifting. Let's fill in our values here. X values, I'm going to have 0, and then I'm going to have a -3, and y values are going to be 5, and then a 4. If I put this in the calculator, the simplified radical form is the square root of 25, which here just so happens to be 5. All right. Those are your notes for the last lesson of this unit. If you have any questions, reach out. If not, we'll see you either in class or in the next video. Have a great day.